Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to the lecture number 10 for the course of Microprocessor Theory and Interfacing. My name is Engineer Jaffar Ali and I am instructor for this course. So as you know that today is our lecture number 10, and we were in the last lecture we were discussing about the interfacing of microprocessor with different devices and different things that you can have in your microprocessor involved with. So the last thing that we discussed about the interfacing was the interfacing of microprocessor with the RAM and ROM. That was the memory portion. So in today's class we are going to discuss about the interfacing of microprocessor, specifically the 8086 microprocessor with the A to D converter. Now before going to that, we will have a brief discussion on the things that are involved. So the thing is basically A to D converter. So we will discuss start the discussion of today's lecture with the introduction of A to D converter. What is A to D converter? After that we will discuss that why this A to D conversion is used and it is necessary for the operation of this microprocessor. After that we will discuss about a specific IC that is basically A to D converter, and the IC is named as ADC 0804. And the last things that we will be discussing in this class will be the interfacing of this IC with the 8086 directly and indirectly using this 82255 IC. So these are 3 or 4 topics that we will be discussing in today's class. So let's start our discussion. So the first thing that comes into anyone's mind is that what is A to D converter? So the A to D converter is basically a device that converts your analog signal into a digital signal. This is now commonly known as A/D. The device that is basically who performs the conversion is known as the converter. So normally the converter is basically something like this, or ADC, analog to digital converter. These are the two you can say nomenclature that are used to display or represent the conversion or converter. So what is ADC? So the ADC is basically a conversion of analog signals into a digital signal. And the thing that why do we need to do this conversion? And the answer to that is basically as shown over here. You can see that mostly in the real world the signals are analog. You can see the light signal, you can hear the sound signal, you can feel the temperature, pressure, acceleration, or any other phenomena. You can feel them, you can see them, but these are mostly analog signals. They are not digital. For example, the intensity of light is estimated or you can say measured as lux, and the sound, and similarly the temperature is measured in Kelvin, and this pressure is basically Hg, mm of Hg, millimeter of the mercury level. So there are many different phenomena that can occur in the real world, but all these are analog. They're mostly analog unless and until you are using a converter. So the natural readings of these phenomena are mostly analog. And you know that the equipments that we are dealing with, that is a microprocessor, these are all digital, all the computer devices, and these are all digital. In the previous portion, that is the midterm, we discussed that how you can manage or interface these things, because there are the machine language involved. So the machine language is nothing but the bits and binary digits. So the first thing that we have to do is basically convert this analog signal into digital signal. So there comes the role of this ADC, or you can say analog to digital converter, where this device performs a conversion from this analog quantity into a digital quantity. And after that we have converted our signal, or you can say either light signal, sound signal, temperature signal, into a digital quantity. After that we can give that quantity into a digital equipment. So this is known as ADC, that is analog to digital converter, and this is basically input to the your digital equipment or any system. There are several examples by which you can understand the phenomena of this A to D converter. The first one is basically the picture. You can see the picture. If you scan a picture, or if you take a snapshot or any picture, you know that this picture is nothing but a combination of different lights. Different lights reflect and it gives you a shadow. So there are different colors or lights. Basically, light is a combination of different wavelengths. Different wavelengths involve different colors. So an image is composed, you can say an image is composed of different lights and of having different wavelengths and different colors. So how do you convert that image into digital signal? After you can scan it, there is a thing known as scanner, and the scanner performs the same operation. It converts the analog signal, that is the picture or a combination of lights, into a mapped quantity in terms of a digital quantity. You can call it bits, you can call it binary. So this is the operation of a scanner. So mostly people call it scanner a converter also. So the reason because of which they call it a scanner as a converter is that it converts the analog signal into a digital signal. Similarly, if you record your own voice or anyone's voice on the computer, on the hard disk, on a mobile phone, you can see that your signal that you are generating is basically analog. Similarly, like I am talking to you right now, I am explaining you lecture, my voice is basically analog, but the computer stores this information in kind of digital. So this is basically the conversion process is taken in this laptop or this mobile phone, and this is known as ADD conversion. And keep that in mind that if you have used ADD converter in the transmission side and your audience is basically the on the other hand side, that the receiving end side, and they are also a same spatial IQ, like I'm a human being and you are also human being, so you will also need to have analog information, because you won't be understanding this information of the, or you can say the burst of ones and zeros. So it will be very difficult for you if you hear 1 zeros in my voice. If I talk to you that 10 10 10 10, you won't be able to understand anything. So you will also need some kind of digital to analog converter, that is the reverse process. I will talk to you analog, the computer will convert it into digital, it will process the whole thing in the digital format, and the user at the receiving end will also get analog signal by a reciprocal or invert function, that is DAC or digital to analog converter. So these are same things, but in 180 phase of shift. You can say that they are doing the opposite operation, and this is known as the whole phenomenon of A to D conversion. And you know that this is written as a note that as a microprocessor only understands the digital signal, so real world analog signals should be converted into digital before you process it. Before you process this, you first have to convert this analog signal that is generated by a natural world, real world phenomena. You have to convert that phenomena into a digital process or digital signal before you process it actually on the microprocessor. So the first IC that we will discussing, there is a series of family of the this ADC converter. The first family is basically 0804 family, and there are several chips that are involved. You can also have a 0803, you can have 0804, and you can also have 0805. These are the same ICs. Companies, the manufacture of these ICs are the same, but there are different variants of this. We will be discussing about 0804 in this lecture, inshallah. That's why I have highlighted it over here. So let's talk about this IC specifically. You can see that in this IC you can have a VCC, you will have a ground. Now there are two grounds available. One is analog ground, the second one is digital ground, and you know that they are electrically they are the same, but if you are involving two pins, that it means you have to do something with both on the pins. So the input that you want to give, you want to convert, is basically given in these pin number 6 and 7. The figure shows that this is the pin diagram, and this in plus and in minus inputs allow the application of different input voltages, which has the common mode rejection and eliminates offset due to the zero input analog voltage value. So this is your basically input, and this VCC and this ground will be your operating devices, or you can say these are the operating hands that will be helping you to enable this device, to activate this device, to turn on this device. Now there are the main things that are involved is basically the CS, this RD, this WR, that is the chip select, read and write, and this one is the clock synchronization input for the input, and this is the interrupt. And similarly here you can have clock output synchronization for the output devices, and at this pins from DB0 to DB7 you will have your after the conversion you will get your bits from here, these pins actually. So how does this process occur? So let's start with the process of this. So before going through the process, let's talk about some brief features of this family or this IC. So you know that from this device you can see that this is basically nothing but an 8-bit successive approximation ADC. And how do we call it 8-bit? Because you can see that these are giving you 8 bits of output simultaneously. You can have these 8 bits of outputs here, so that is why this is basically 8-bit this ADC. The conversion time of this IC, specifically this 0804, is basically 100 microseconds. The access time is 135 microseconds. It has one chip clock generator, and it does not require any zero value adjustment because it is already done over here, and it operates at 5-volt power supply. The output should meet the TTL logic specification, so we will discuss that in class also, inshallah. Let's talk about the operation of this ADC, specifically this 0804. So when this WR goes low, the input successive approximation SAR register is reset. So as long as this is low, there is nothing going to be happen. But when this CS, this chip select, and this WR remains at low, there will be this ADC will be remain at its reset state. Nothing will be happen. But after you make a transition from low to high transition, and after 1/8 of the clock time that is mentioned, the time period that is mentioned, you can also find the clock time. I will show that how you can find your clock time in the next slide, inshallah, in the next slide in this lecture, the same lecture. But after it goes from low to high, both the CS and WR, when it makes the low to high transition, the 1/8 of the second, 1/8 of the total time period will be the time that will be there for the basic conversion starts. So after that time the conversion will start, and once the conversion gets start, you will won't be having any control on the converter. You cannot use your interrupt because the interrupt will show as busy. So as long as the conversion is going to be taken, the time taken, so there will be a busy state for the interrupt, and you cannot access or enable this interrupt because it will show you the busy state. Now as this is the process of the conversion, as long as this interrupt will high, and this data will be converted. So you can see that this is the right operation, and as long as this is basically high, the process is going to be taken. But for how long? Unless and until this CS goes to low, and after that 1/8 of the second time period, total time period. So after 1/8 of again the 1 to 8 time of the clock time, it will be reading taking the conversion process over here. And at that time, after 1 to 8 excuse me, 1 to 8 clock, this conversion will be stopped, and after that you can use your interrupt pair. Now how do you read your data that after the conversion, what is the output? So for that you have to make this CS and this RD low. As soon as you take this CS and RD low, you will have the option to read your data. After this line you will be reading your data. at this point you will be reading your data. And how do you read your data? By taking that to these output ports, that is from DB0 to DB7. So this was the whole small process for this. Let's talk about the internal circuitry of this ADC. So basically, you know that we have already discussed about the op-amp, that is operational amplifier, in the previous semesters, and these have two, let me write it down. Op-amp, you know that there are two kinds of op-amp. One is inverting and the second one is non-inverting. You can have both of these. You can see both of these over here. So these are the internal circuitries for this ADC. And how I talked about I discussed that you can find the time 1/8 of the I told you that there is 1/8 of the clock. So how do you find the time period of the clock? So for that you first have to find the frequency of the clock, and for the calculation of the frequency you can see the formula is mentioned over here. The clock frequency is equal to 1 divided by 1.1 into the value of R and C. R and C is basically the resistor and the capacitor that you have to interface with this ADC before actually working on it, and this R and C will help you to find the clock frequency. After you get the clock frequency, you can take it as you can find the time period of the clock by dividing it by 1. So if you do this kind of formula F clock, you will have the time period of the clock. So this is the formula, and 1/8 of that time will be counted as the read or write or the conversion operation. So you can find these things as well. Now this was all about the operation of this ADC. Now let's talk about the interfacing of this ADC with the 8086 microprocessor. So for that you can have two modes. The first one is directly, and the second one is using this 8255. So let's talk about the first one, that how do you connect it directly. So this is a small code that you will be needing, and let's talk about this code. You can see that I have the address of the interrupt is basically, I have put in the interrupt address as 80, and the converter to address the read converter is basically 82. So this is basically the pins of this 86 microprocessor from A0 address bus from A0 to A7, and these are also this is the memory bank of register bank of at the address of 80H, and this is the address bank register bank at the address of 82H. So you can see that this is your decoder. If you want to do it directly with 82 this 8086, you will be needing this small decoder, and you can see that this decoder has multiple inputs and few outputs. This, let's say this Y2 is as the output. So this Y2 and Y0 will be controlling this CS, and you know that by controlling this CS you can actually control this conversion. So you can control this conversion by using this decoder, and from there you can get your output of the converter. You can store it where do you want to store it. So these will be your output, and the remaining things will remain the same. The clock register, the clock, the reference value, the ground, analog ground, as you can see that we have grounded the analog one, and this is your analog input, and this is your read and write operations, and this is your interrupt. So this is how you connect your this whole ADC with your 8086, and the code, let's go over. Let's talk about this 86 microprocessor, the code actually. So you can see that here you have described that this is the procedure to read the data from ADC. How do you read the data? So the procedure is mentioned that this is near, and the output is basically, you can see that this, you have the comments are showing the things that are actually being done by the use of this command. So by using this command, we have basically started the conversion. We have forced the conversion to get started, and after that we are keep reading the interrupt. As long as the interrupt is busy, we will be jumping at this again and again, unless and until this interrupt becomes to 0. I told you that whenever the conversion is going to be taken place, the interrupt will be busy. So as long as it comes to 0, we won't be touching anything. So we will check about the interrupt value. As long as this interrupt is there, the value is not equal to 0, we will keep jumping on this again. You can see that we have used this JNZ, that jump not equal to 0, jump if not equal to 0. So you will be keep jumping at this label, that is the label again. This is label, you know that this is a label, and you will be jumping over here again and again unless and until this interrupt value becomes to 0. As soon as this interrupt value becomes to 0, you will come at this line, and after that you will be able to read your data, digital data in the arithmetic AL. And after that you have read your data, you can basically return to the actual value, and this is the end of the program. The read program is going to be end over here. So that is how you can basically read your data with the use of this 8086 microprocessor. Now let's see more difficult, or you can say more complex structure. I've told you that there are several options by which you can connect your ADC with 8086. If you are using multiple ports, are having multiple ports for inputs and output, you can see that this 8255 can help you to be able to connect different ports. There are port A, port B and port C. The pins of the ports are allocated from 1 to 7 for each of the port, and you can see that there are the output ports from D0 to D7. These are the data pins, and this is the same ADC, and this is now connected to this port 1. So you are reading your data of this ADC and you are storing it into the PA. Let's talk about an example. In this example you can see that we have a code. Let's talk about a brief code over here. In this example, you can see that the first thing that we have done is basically we have declared port A and port C as an input, and port B will be our output. After that we have made this write command high. You can see that we have made this write command high by giving it all ones, and after that we have started the conversion at this line. This line has the conversion started, and the same process will be going over here as well. You can see that this loop is basically for the checking of the conversion. As long as this interrupt is not equal to 0, this will jump back to the label, and that is back, and it will be keep jumping on here and here unless and until the conversion gets stopped. Once the conversion is completed, the interrupt value will become equal to 0, and after that you can read your digital data in any of the port. So this is the one kind of complex problem for interfacing of when you have multiple ports, or you are using the microprocessor or your ADC by a microprocessor with multiple ports. So you can see that there is port A, port B and port C. Each port is on different location or address location, and there is another port of control register, and it is also having a different address. So by using this kind of circuitry, you can interface your 8086 with your 0804 by using 8255. So that's all for today. I hope that you have learned quite a lot in this lecture. I know that this is quite a complex lecture to understand, but I will highly recommend if you watch this video at least twice before coming to the class. We will be having a good conversation and discussion on this topics, inshallah. So bring some good questions with yourself. I look forward to see you in the class, and I will be very happy if you ask me some good questions. That's all for today. If you have any questions, you can put forward that your questions or confusions or queries on my email as well if you are not able to attend the class for any reason. So you can also reach me by my email address. I'll see you in the class. Thank you very much. Allah Hafiz.